Good afternoon, everybody. Congratulations on making it to the last session of Wednesday. Appreciate the opportunity that ARC has given Dow Chemical to participate in this forum and particularly in this session. I'll start with giving a brief introduction to the Dow Chemical Company. We're a large global chemical company. We combine the power of science and technology with the human element to innovate what's essential to human progress. A snapshot of Dow, we have around 700 assets on 200 sites in 37 countries. We have been heavily involved in several divestitures and mergers lately, and so I won't vouch for the exactness of those numbers, but you probably get the idea. We have customers in 160 or so countries. We produce more than 5,000 different products. We range in everything from batch plants that sell into the pharmaceutical industry and have to deal with the CGMP regulations, batch plants that sell into automotive. We also have very large continuous plants that may run for 7 or 8 years before they take a scheduled turnaround, and so they have higher reliability needs, less batch reporting needs, and so we have a wide variety of plant needs that we have to satisfy. Our headquarters are in Midland, Michigan. We have sites all over the globe. Our largest one is in Freeport, Texas, which is where I'm located. I've been there for about almost 30 years, and I am part of the Central Engineering Organization. I'm the expertise area leader for continuous process automation, as Mark said, and I'm also the technical leader for the process automation migration program that we have put in place to migrate our legacy systems, our proprietary legacy systems, to commercial ones that I'll talk about a little bit. And I'd like to acknowledge a colleague, Andre Schapens, our global discipline technology leader, located in the Netherlands, is actually the one who was asked by ARC to present this topic. So he did prepare the presentation. He wasn't able to make the trip, and so you're stuck with me. But anyway, his presentation, but I'm going to do the best I can to fill in for him today. So there's 4 topics covered in this presentation. What is process control all about? Past evolution, current challenges and opportunities that we're facing, and what's next. And of course, all of this is, somewhat from a Dow perspective. It probably mirrors pretty closely what a lot of you are experiencing, but may have some slight differences. So what is process control? Focus on the S95 level 2 area. As I said, we have both batch and continuous, as well as some discrete operations. We have a strong interaction between S95 levels 2 and 1, and also level 3, the MES, and the emphasis on that is growing as the desire becomes more and more to connect with the enterprise level. So that's an area in which we're trying to grow. Process control is, as all of you know, more than just controlling valves. It goes beyond the application of control theory. We deal with discrete and analog control, sequencing of events within a unit operation and between multiple unit operations, and sometimes even between different facilities. We incorporate safeguarding and interlocking, including our safety instrumented systems, but not limited to that. Also, reporting requirements, again, heavier requirements for the batch processes, but also applicable to some extent to our continuous processes. And then the operator HMI. In some of our larger facilities, we have one operator responsible for several thousand IO. And so they have a need to have a good overview of the process, as well as strong capability to be able to drill down and see the details of the different areas that might be problematic at a given time. We also deal with various plant conditions. Dow tends to highly automate our facilities, not only in the run step, but also through all the way from being down through startup, running, shutdown, abnormal situation management, including some trips, partial trips, capability for warm restart, that type of thing. So we have, that's something that we have implemented with a methodology called state-based control. We have proven value in that from being able to start up our larger facilities more quickly than industry benchmark, and also reducing batch cycle times when we've implemented this. So a high level of automation is something that we highly value and focus on and intend to maintain. A little bit about the evolution of process control. So Mark covered that very well in general terms. I'll give you a little more of how that similar progression went in the Dow Chemical Company. We originated with an instrumentation-driven process where the plant would be designed, the instruments are there, and oh, by the way, let's get somebody to program something so we can run the thing, right? Somewhere in the 70s or so, we had some chemical engineers that had a vision for some potential value in doing more with automation. And they actually designed a prototype of a control system, as the story goes, in one of their garages. And that evolved into a Dow proprietary control system called the Mod 5. And through it was designed by chemical engineers for the sole purpose of, what they believed was needed to operate a chemical plant. And Dow standardized on that system and implemented it throughout our plants in the 1980s and 90s. And that really changed the role of the operator as we implemented state-based control on those systems, from needing to worry about how every valve was managed and flipping on the control for each piece of the plant, to really interacting with the process more at the unit operation level. And telling a unit operation to start and initiating a series of events, and then monitoring the control system and any alarms that came in and any abnormal situations and such. So that really changed the role of the operator. And that brought in with it some intelligence. Yeah, there I'm pointing at something. Some intelligence that gave us consistency in operation. So behaving as if we programmed a lot of our operating discipline into our systems, behaving as if you had your best operating shift, on staff every shift. We also were able to automate some of the riskier activities, and we really, we did pretty well with that. Somewhere in the time frame of the mid 1990s, I guess, there was a recognition that 1970s computer technology probably was not going to last forever, and so we needed to look at the next generation of control system. And after doing some internal evaluation, there was some study done of what had evolved in the market since we started this, and really found that the capabilities in the market had improved and evolved quite a bit. And at that point, our upper management decided that we really should focus on being a chemical company and not a computer company. And so the choice was made that for our next generation of systems, we would partner with an external vendor and implement a commercial system, working with them to ensure that we could implement our state-based control theory on their systems as we wanted to do that. And so for about the last 10 years or so, we have been implementing commercial systems for our new plants. We're just recently starting the journey of migrating our legacy systems. We have a quite large installed base of that. It's still over 60% of our installed base, even with the acquisitions and mergers and divestitures and everything. So we have a large job ahead of us there. But the newer systems brought with them, integrated solutions with enabling much greater capability in terms of vertical integration, and really just endless possibilities of what you can do. Those possibilities, though, then bring us some responsibility for evaluating the possibilities versus the needs. And I'll give a very, very simplistic example, but this is much more broadly applicable. So if you think about alarms, in our proprietary system, at least in the first version of it, there was a finite number of alarms that we could program per system because there were only that many slots to display them. And it was, it averaged less than one alarm per I/O point, depending on your configuration. So you had to be very selective about what alarms you needed and maybe combine some of them and whatever. But there was some built, and also to program it, our language was kind of similar to Fortran. So if you wanted to program an alarm, you typed a line of code that would execute that alarm. So there was effort involved to do that. With the newer systems, the limitations are gone, right? And the configuration is very easy. You can get 4 I/O-based alarms, high, 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 low, 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 with the check of a box and enter a set point, and you're done. It's very easy. And it can be tempting to think, oh, well, look at all this I can do very easily. That would probably help me. But if you're not evaluating the need, can actually hurt you if you clutter up the system. And I know that's a very simplistic example, but it applies more broadly as well. And then, as Mark mentioned, of course, these new systems use the generic IT technology, which we didn't really have a lot of that expertise in our process control group because it was not needed in the past. So that's another area that is different and has changed the skill set needed. And we've talked a lot in this year's forum as well as last year's about the opportunities to integrate IT and OT. So what are some of the challenges and opportunities we're facing? So cost versus benefit. Talked about that a little bit with the alarm example. We are really trying to be aware of the technological possibilities, but then also justify the business value of pursuing those, and not just putting stuff in because it looks cool or seems like the latest thing. That can be challenging to evaluate. We also need to make sure that we achieve the appropriate balance between efficient project execution and our manufacturing needs. You can execute a very efficient project, fast, low cost, meet all the metrics, but if the final product does not meet the needs of your manufacturing facility, you really have not accomplished your objective. And so we need to make sure that we plan our projects accordingly to meet the business objectives at the end. One thing that is a key for us is our DCS configuration skills versus plant operating expertise. So in the past, with our proprietary system and our operating model, we mainly trained chemical engineers to do the programming. And so that understanding of the chemical process and how the plant operates was already built in. We didn't have to teach them that, just had to teach them how to write some code. So that worked very well for us. That's not as easy now with the newer technology. It's more complex, and not that they can't learn it, but if you take your chemical engineers and try to make all of them IT professionals, you're probably not getting the most out of their chemical engineering abilities. So that's another, a different balance that we need to find. Another challenge, embedded operating knowledge versus IP leakage. So as I mentioned, we tend to program a lot of our operating discipline into our control programs. And that's a lot of our, our competency is, that process understanding, and it's all in that program. Now as we're using different control systems which that and other factors move us a little bit more toward outsourcing, we have to be very careful that we understand the intellectual property needs of each of our businesses, and we do have very diverse needs there because of the diversity of our business groups. And so we have to do a careful evaluation of that and ensure that we make the appropriate choices for what we can outsource and what we can't, and how we continue to protect that intellectual property while getting the external help that we need to program our systems. Other challenges around people resources. Now that we are more dependent on the IT component, we're getting into competing for resources that have that skill set, who may also have opportunities to go work for the Googles and the Facebooks and the, all those fun companies in the world. So incentivizing them to deal with the realities of what's needed in industry versus going to one of those jobs that may on the surface at least be perceived as more fun can be a bit of a challenge. We have always relied heavily on highly capable resources. And while it's still very important that we identify, recruit, train, and retain highly capable resources, it's less and less likely, as Mark was saying, that you're going to get everything that you need in one person. And so now we have to focus more on developing highly capable organizations where all of the people who have those different skill sets are able to collaborate effectively to share what they need to share to be able to get the job done. We need to maintain and identify what's the appropriate level of process automation expertise within our manufacturing organization. We have never outsourced all of that work, and we're not willing at this point either to get in a position where if we want to make minor changes or updates or even do small projects that we're dependent on bringing someone else in. So that's something we have to look at on our projects. We need to develop some amount of expertise on these commercial systems that so that we can do our own, have some autonomy and do our own maintenance going forward, which may be a little less efficient than just outsourcing all of the configuration to, an offshore site. But for us, we've got to balance both needs as we're executing our projects, and make sure we maintain the correct internal capability as well to serve us long term. And then finally, we want to make sure that we invest appropriately in both people and technology. If used and developed correctly, technology can improve the way our people work, but we need to make sure that we're using it as an enabler, and then also devoting enough resources to our people specifically in their development. So what's next? We are just finishing or coming near finishing anyway, a cycle of some significant capital investment in some very large new facilities in various geographic locations. And so we had a lot of our capital and our people tied up in a lot of those large capital projects. So some of those resources will be freeing up to do other things in the near future. And so one area we're going to focus more is investment in our existing assets. And so we have our life cycle challenges to address, as was mentioned, as I'm sure several of you are facing. And so with these process automation only projects, we have initiated a program to address the obsolescence issue. But as we implement that, we do want to bring business value with those projects as much as practical, while balancing that with how much risk we introduce. There's a lot of risk inherent in any migration project. It's a significant change, and we've just got to, we want to create the value, but we've got to balance that with not trying to do too much change all at the same time and getting ourselves in too much trouble. We also intend to focus again more on some PA improvement projects. We've had some success in the past with sending small teams to a plant, evaluating the operation of that plant against key performance indexes, identifying business value for making improvements, and then leaving that team behind to actually make the improvements. During capital intensive times, we typically are resource limited and not able to do as much of that work. So there's some intent to work on that a little more in the future. And we are trying to stay abreast of this new technology paradigms that we discuss so much in these forums, to understand what's available, but then evaluate the business value of what parts of this can really help us, because our bottom line is to make chemicals more efficiently, make more pounds, make more on-spec pounds, and so we've got to make sure that we identify the business value that these things can bring us. Also, increased focus on our organizational dynamics within our central engineering group. We support build projects, technology projects, and plant support projects, and so finding the appropriate balance of getting all that done is always a challenge. Addressing our skill set requirements. We already talked about IT and OT and manufacturing expertise and the balance there. But as Mark, I believe, mentioned, another big thing that we have to worry about is maintaining our installed base of the older technology, because even though we're starting to migrate it, it's a multi-year effort, and so we will have to maintain that expertise until we can get all that work done. Issues around current workforce versus the future workforce, that's been discussed as well. It's very important to us before these 10,000 people a day retire that we capture their knowledge. They have so much knowledge that they've built up in plant operation and project execution and such. It's very critical that we capture that knowledge and leverage it to this future generation who is so at ease with all the new technology. And if we can do that effectively, we really have the potential for them to see how to embrace the new technology and apply it to further our business goals. And so my last slide here, a summary of what's coming tomorrow. What we're attempting to do is to embrace new technology while still keeping focused on our core competencies and ensuring we've got the proper ratios between owner and contingent staff, DCS configuration skills, and plant operating expertise, and making sure that we make choices that actually add value versus just being nice to have. We're focusing on integration of run the plant functions with run the business functions at the enterprise level, and again, doing that vertical integration as it makes sense and can add value to us. That does require some changes in the organization, and particularly to manage all the variability and complexity we have in our installed base. And so in summary, our intent is to provide a value case-driven process automation solution offering to both our new and existing technology. But as you all know, there's many challenges associated with doing that. So that is what I had for today, and I'll turn it over to Dex, I believe, is next.